All right, let's do a quadratic graph word problem. Now this one I particularly chose because a lot of students have asked me about this one so far. They seem to have a little bit of a hard time with it, or maybe it just looks scary. So let's go ahead and look at it. We've got an aeronautics problem. At liftoff, the Space Shuttle Discovery has a constant acceleration of 16.4 feet per second squared and an initial velocity of 1341 feet per second due to the rotation of the Earth. The distance Discovery has traveled, t seconds after liftoff, is given by the equation dt equals 1341t plus 8.2t squared. How long after liftoff has Discovery traveled 40,000 feet? Round your answer to the nearest tenth. So let's go ahead and look at this. Now, if it looks like there's a lot of stuff here, right? And well, there is a lot of stuff. But please note that the constant acceleration of 16.4, this one right here, has to do with this 8.2. You'll notice that half of 16.4 is 8.2. That's a little bit of physics. Don't worry about it. That 16.4 is right there. All right. Then it gives us initial velocity of 1,341. Again, here it is right there. That's not an extra piece of information that you need. It's already put into the equation for you. They keep telling you these types of information and then give you the equation in the hope that you may eventually recognize that the number in front of the linear t is the velocity, and that the number in front of the quadratic t, the t squared, is half of the acceleration. Okay? So hopefully, as you see more of these problems, you recognize that pattern. So now the question is, how long after liftoff has Discovery traveled 40,000 feet? Well, if we just put that into the distance, right, you can go 40,000 equals 1341t plus 8.2t squared. Now the problem with putting this into your calculator is that if you type this in for y1, you now have to solve for the graph being equal to 40,000. The calculator won't allow you to just give a y value and get the x value out, because different y values could have more than one x value is the problem. You can do that for the x-intercept when y is 0, but you can't do it for any other y value. There's various ways of getting around this, one of which is creating a separate equation for this side, which we've done before with linear graphs. We found the intersection because we made two different equations and found where they cross. But the way that I would recommend doing it, because it puts it in a format that we're familiar with, is to get it equal to 0, right? That's what you're supposed to do with the quadratic anyway. And so let's subtract the 40,000. And so we're going to move it to the other side so it's equal to 0. And at the same time, I'm going to rearrange it so it's standard form. So it's going to be 0 equals 8.2t squared plus 1341t, and then minus 40,000. Okay, so now we can go ahead and we can put that into our graph. So let's go to the y equals screen. Oops, I guess I got to turn it on first. So y equals, clear whatever's there, and type in the equation. 8.2x squared plus 1341x minus 40,000. Okay, and we go to graph. So it's busy. So oh no, it's not busy anymore. It's done. I don't see anything. What do you think? Well, I think the reason why I'm not seeing anything is because the y-intercept is negative 40,000. Okay, that means that our window needs to change. We need to adjust this somehow so that we can see those values. So let's do that first. Let's take care of it so that we can actually see the y-intercept. I don't know how high it needs to go, but I do know it's got to go down to 40,000. So let's go into our window. So there's window. And we're going to change the y minimum to negative. I'm going to go a little bit more. So I'm going to go 45,000. The reason is just so I can be a little bit below the intercept and I can see a little bit more. So enter. Let's go ahead and graph it now. See what we got. Oh, there it is. I can see it now. I can see it now, right? Now, we actually want the place where the y value is 0, right? Now, you can tell that right now we're at a, remember the y-intercept is negative 40,000. So we're at negative numbers now, but it's going up. So really what I need to see is I need to see more of the stuff over to the right here. Right now, my x value, if I go to my window, you'll notice that the maximum x value is 3, right? 3 obviously isn't enough. I need to go to 4, 5, 6, 7, and I don't know how high. But let's make a guess. Let's say, okay, let's try maybe that we need to go up to 20. I don't know. Seems reasonable. We'll give it a try. So we'll graph it. We'll look at it. There we go. Here comes the graph. 20 didn't quite fit, but that's all right. You can tell that you can now see a little bit more of the graph. Okay, now I'm going to do two things. I'm going to extend it so I see a little bit more there, and I'm going to extend it so I see a little bit more of the y values up top as well, because I can't really see the x-axis very well. So I'm going to go to the window. I'm going to change my x max. Let's go up to 30 this time. 20 was pretty close, but we'll go 30. And then I'm going to change the maximum y value. We'll just go 5,000, just so I can see a little bit more up there at the top. Okay, and so now we've kind of played with the window a little bit. We can see how we can see a little bit more at the top. We can now see the graph. Now, at this point, you really didn't have to do all that graphing stuff. If you want, you can use the quadratic formula here. You can do negative b plus or minus the square root of b squared minus 4ac all over 2a. The problem is most people look at this and say, those numbers are too big. Yes, those numbers are big. That's life. Deal with it. Life has big numbers. Life has small numbers. Sorry, that's how things are, right? When you work in a bakery, you make hundreds of loaves of bread a day. You're going to have to deal with big numbers, especially if you're looking at years or the bigger time period you look at, the bigger your numbers are going to be. No matter what you do, you're going to either be dealing with probably very large numbers or very small numbers. Okay, and so yes, we need to find where the y value is now 0, and so we need to find the x-intercept. So we can do that by using some math in our calculator. So that's F5. So we go to F5 and we can go to the 0. Remember, the 0 is the x-intercept. So we'll go to 0 and push enter. Now it gives us our familiar question, lower bound. Lower bound just means we need to be the left of this x-intercept. Okay, so it is. So I'm going to push enter. And then I'm going to go to the right. Now the whole purpose of the bounds is you are setting boundaries for where it's going to look for the answer. If there was another x-intercept here, I would need to put my boundary farther over, because you want to make sure that there's only one intersect inside the boundaries that you set. It's the same if you're looking for maximums, minimums, but I've gone to the right. So now I'll push enter, and it's going to now calculate that x-intercept for me. Now you'll notice that it gives me a y value of 1 times 10 to the 9th. That's what the e means, times 10 to the negative 9th power. That's 0.0000000001. Now I may have put in an extra 0 or something, but you get the idea. That's pretty dang close to 0. It's all how the calculator does its calculations. It doesn't actually plug in a 0 and solve. It actually puts in x values until it finds something that's 0 or pretty dang close to it. And so we get a 0 of 25 point, if we round up, 25.8 seconds. So t equals 25.8 seconds, which is what it asked for to the nearest 10. So after 25.8 seconds, the shuttle has traveled 40,000 feet. All right, so hopefully that was helpful. I'll put up one more.